Power up. Welcome to Energypreneurs, where I bring to you the exciting new opportunities in solar power, battery, and electric cars. I'm your host, Sohel Hasni. I have been tracking and analyzing these technologies on LinkedIn and Twitter for more than 10 years. Now we meet on podcast. Okay, good morning, Vinod. Finally, nice to be able to catch up. We briefly talked about a very exciting field, no, that you are working on batteries. So maybe I'll ask you to introduce yourself first, and I'm really happy to be able to finally connect with you.
So my name is Vinod Nair. Okay, I'm an electrochemist. I'm working on this battery area for last 30 years now. Okay, currently I have a company in Silicon Valley called FaradPower. Where we develop advanced battery materials based on sustainable technology. Okay, so our technology differentiator is that we make this material from agricultural waste. Okay, so right now the problem with the battery technology is an important problem, in my opinion, is supply chain. Okay, because battery technology, they need specialty materials, graphite, nickel, cobalt, lithium. Okay, all these materials you need, but unfortunately all these materials are geographically constrained. It is not available everywhere. So it is a big problem. Okay, so that is the problem we are working on. How we are solving the problem is, for example, our technology is based on making anode material to replace graphite, other carbon, what we call hard carbon material.
So you want to replace the anode in a lithium battery from graphite to something else?
Yes, graphite, more sustainable material. Okay. The graphite, the problem is that they are using two types of graphite. One is synthetic graphite, another one is called natural graphite. Okay, so both of these processes are big issues because natural graphite mining, as you know, it is a big polluting process. Okay, so one day they have to.
Which countries have natural graphite?
The natural graphite is available in most countries, like in China, for example, they have a lot. In Australia, in India. A lot of different countries, they have graphite resources, but I don't think most of these countries have developed this material to battery grade material from natural. You need to do a lot of development work to make it battery grade graphite material. So that what the Chinese government was doing for last 30 years. Okay, so they developed that graphite, and they are now enjoying what they have done, because they now own more than, I think, 80% of the anode material market in the world. Okay, so that is the situation. Even if you have a graphite mining, go ahead.
That is one kind of graphite. So you said there was a second kind of graphite also?
Yeah, that is also dominated by the Chinese industry, because you need to have a lot of energetic process for making it. Synthetic graphite, we call it synthetic graphite. So it needs to you need a special process and everything to make that high temperature heat treatment. Okay, 2000 degrees centigrade. Okay, more than that. You have to heat your material and everything, and that also dominated by the Chinese industry, battery industry. So right now the graphite industry is more than 80% is dominated by the Chinese suppliers globally.
Okay, and then your company is trying to change that in a way. You are into R&D and you are finding a naturally occurring alternative. Wow, that's fantastic.
Yes. So what we do is, do that from agricultural waste. Okay, in Philippines, for example, they have a lot of this rice farming. In India, those Asian countries, and everywhere globally. Okay, so the advantage with our technology is that we can make this from any feedstock. That means whether in US we have a lot of corn farming, South America they have a lot of sugarcane farming, right? Different countries, they have their own agricultural farming, right? So our technology, what we develop is that this agricultural farming, after agriculture and harvest and everything, you have a lot of waste. Okay, from that rice farming, so, rice harvest, you're very much familiar that rice straw, they have a big problem that you have to handle that rice straw. Okay, everywhere, you cannot
So
burn
the
it because it is.
rice straw can be also used as a feedstock.
Yes. So rice straw is a big problem, right? Burning of rice straw is a polluting, and you don't know what to do. You don't want to put back to the soil or the all of it. You can put some of it. So our technology, the interesting aspect about this are this what we call biomass, whether it is rice straw or whether it is sugarcane waste or whether it is corn cob waste or whatever. All of those components, they have something in common. I mean, they are all made up of cellulose, hemicellulose, and lignin, 3 components. Okay, so our technology is based on hemicellulose. That means we can make it from any of this biomass. Okay, so hemicellulose is a part of biomass that we take, and then we make our carbon from that. Okay, so it is that means once we develop the technology, we are doing it for last 10 years. Okay, and we are talking to people to scale up pilot line and production and everything. So once we do this thing, we can go and build this plant all over the world. Okay, if Filipino and in India, we are talking to Indian battery industry. I will talk lot of interesting thing about that in a minute. But there, is an opportunity that they have a lot of the sugarcane plantation, sugarcane waste. We are talking with them how we can implement our technology for making. So once we have developed everything, commercialized globally, we can go and build this plant for LIB anode material all over the world. That is idea. Okay.
So this alternative to graphite anode material, how does it look like? Is it similar in weight and other characteristics as lithium? Because lithium is quite light, no?
Yeah, it is not lithium, right? It is graphite.
Sorry, graphite. Sorry.
Yeah, graphite. Yeah. So graphite, it is similar to graphite, and the advantage is it has better performance. So of course, we can do everything. People like talking about this pollution, environmental things, and everything, but you have to have performance improvement also. Okay, so that is what we are trying to do, because next generation lithium batteries, if the industry is highly competitive, if they want to adopt our technology, we have to be highly competitive also. What we make is not only just carbon, what we call it carbon silicon composite. Okay, so
the graphite is basically the tip of this pencil, right? That's the graphite.
Yes,
part of it.
Yeah, that is graphite. Exactly, that is graphite. Yes. So we are trying to not only just replace graphite, also we are thinking about next generation beyond that. Okay, because as the battery technology mature, you need a better anode material than graphite. So graphite performance is already capped, right? There is nothing you can do with the graphite. Okay, so that is what we are trying to do. Our technology, we are also aiming to actually increasing the performance of anode material. So right now, for example, the capacity of cathode is 350 milliampere hour per gram. The industry is looking for like 700 milliampere hour per gram next generation, with the silicon.
So it's a 300 milliampere per gram. And
350.
350, and you think your technology can push it to 700, or the industry is looking for 700.
Right now all we have to do is for replacing, maybe get slightly above 350, and eventually we have to get into 700 milliampere hour per gram to match with the next generation batteries, increasing energy density and other things. Okay,
good. And where are you exactly in terms of this R&D? Are you in the commercial stage already? You have batteries that you have produced, or you are still working on the anode side of it?
So we are working on this for last 10 years, the technology. We have already granted 10 patents for the technology globally, including in China. Everywhere we have patents about the technology. And right now what we are doing is talking with commercial partners, large partners, large companies who are making, for example, graphite or silicon, or any of other chemical companies who are interested in getting into this battery anode material manufacturing. Okay, so right now we are actually started the discussion how we can get into the manufacturing. And for example, like I was telling you, in India, they have a lot of this raw material sitting there. And so they are looking for a battery material supply chain. Okay, so we have some discussion going on and how to utilize that facilities, and do the anode material manufacturing. So that is our plan. Similarly, in different countries, we approach people who want to do this thing. Okay, the farming community and things like that.
Yeah, because few of my listeners, I don't want to put a name right now here, but one of my friend actually working on a battery factory in Bangladesh, and he would be
Okay.
very interested. And we discussed briefly this topic, but I did not know the details of it. And I know a few other colleagues globally who will be very interested on this technology. Wow.
Okay, I'm happy to have a discussion. I have a lot of discussion going on right now regarding this. Okay, yeah, so I'm happy to help.
I'm happy to connect with you.
Yeah.
So
Okay.
tell me a little bit more about your company. How large it's the setup? You mentioned you have 10 international patents. That's quite significant. Yes.
Yeah, so the interesting thing about our company is that we are distinguishable from others because we are only just basically the owners, just the two of us, me and my CEO. Okay, and he is the investor also. Okay, so we haven't taken any external investment so far from anybody else, or only a little bit, some angel investors somewhere. When we talk to people, they sometimes, okay, I want to put a little bit of money, you know what I mean, right, into your company. Okay, so other than that, no major investment. Okay, so we got some government grants, US Air Force and everything. And other than that, unlike other companies in the Silicon Valley, normally they raise like a huge amount of money, get like, our competitors are all now going to public. So they are all valued like, more than 10 billion with a B. Okay, so we haven't done anything like that to, raise the money. So what our approach, we want to keep it very, what you call development ourselves, and take the technology and then commercialize rather than, okay, create the buzz in the beginning and, tell everybody that we have this thing, that thing, and finally, struggle to reach that there, in a lack of a better word, I will say, rather than creating a hype, okay, that we haven't done. So we wanted to do, both of us are PhDs. So basically, to answer your question, the company is just owned by the two of us, and we do all the work, basically. Okay, we have all those supporters and everybody, advisors, lawyers and everything else we have, but basically we do everything ourselves. And we have this project with the US Air Force, with the Penn State University, so that they do all the battery testing for us. Okay, we have a lab in Silicon Valley where we make the material and we send it to Penn State. They do all kind of battery testing and everything, material characterization. Okay, yeah.
So 2 scientists working out of their garage in partnership.
Not garage, we have a lab in Silicon Valley. Yes, we have a lab.
You are working with the Penn State University, of course, you mentioned. I'm just saying that.
Yeah.
It's a big thing. You're trying to change the world, because if but I mean, globally, lithium-ion battery right now is a very, very hot product. No.
Yes, and very, very hot product. And if you think about it, graphite replacement is very, very important in that aspect. Okay, because that is one of the significant component, right? Even if you have a lithium and everything, and it is very important to replace graphite right now. And then maybe I can add few more thing about our technology, or you. Yeah. So our technology is basically about making carbon, like I said, advanced carbon. We call advanced carbon from this, agricultural waste. And the way we are making it is the part of agricultural waste, anything you take, rice straw or, wheat straw or sugarcane waste or corn cob, you can get this hemicellulose from that. From hemicellulose, we call a molecule called, we make that furfuryl alcohol. Okay, we call that molecule called furfuryl alcohol, and then that we polymerize and make carbon from that. That is our core IP. Okay, that's our core IP, how to make carbon and everything from this. So this process can be not only for anode material, we can use for several other battery applications, which we are working on. For example, we can use same technology to make next generation lithium sulfur cathode material, okay, sulfur cathode material. And then we can also use for making, I don't know, you're familiar with the supercapacitors, supercapacitor also, both electrodes are carbon. So we can make a supercapacitor carbon material from that. So we can make a lithium sulfur battery cathode material, supercapacitor, both electrodes, and then the other emerging technologies like metal lithium air battery electrodes. Because that is also you need a carbon. For the carbon is actually core of battery technology. A lot of different things. Whatever technology is emerging, you need a carbon particular form, what we call a particular type of pore size distribution and surface functionality, and all those control is required for different applications. So that we can do with our material or our technology for making lithium sulfur, lithium air, and supercapacitor application. And also, interestingly, you might be also hearing a lot about sodium ion batteries, right? Sodium ion battery technology. Yeah, sodium ion battery technology. Also, we have some projects going on where we take this raw material and make anode for sodium ion batteries. So with regard to sodium ion batteries, it is interesting that you cannot use graphite for sodium ion batteries. Okay, that is a problem. You cannot use it, even if it is available. Okay, so there you have to replace it anyway. Okay, so we are working on that also. So we have this wide range of technology roadmap, but right now the focus is only on this, making this anode material, and eventually get into the other technologies in the future. That is a plan.
Yeah. Because I mean, going back to my high school days, when we used to cut open a simple C-size or D-size battery, that core is graphite, no?
Yes, that is graphite, exactly.
Yeah. So graphite is everywhere. What are the other uses of graphite beyond batteries? There must be a lot of uses.
Lot of uses. Graphite market, for example, the last, I think in 2020, it was like 440 kilotons, okay, for the battery application. Okay, the overall market, I will say maybe like 2 million tons. Okay, plenty of application for graphite. It is not just batteries. Yeah.
So if you are able to replace the battery side of it with recycling, or what you call the agricultural material, I mean, that could be quite significant. What keeps you wake up at night? You must have a lot of things going on in your head any given time.
Yes. Yeah, a lot of things. Actually, I had to wake up night because when I talk to the Chinese companies, okay, they want me to talk midnight. Yeah. So sometimes I had to wake up middle of the night and talk to them also. Okay, Asian company, I mean Japanese or Chinese, basically. Yeah.
Yeah. So
you are the one. You are the one first one ready to wake up 8 o'clock. They are not ready to wake up. They normally do it at 11 o'clock. Okay.
Yeah. So Vinod, what else are you working on other than these batteries? What other things you're passionate about?
There is nothing other than this I do, because it is occupying everything, whole my life. Okay, you can imagine that we are only 2 people in the company, and this is basically my passion, and there is nothing other than this I do, really. That is the thing. The other thing I can add, that is one thing I'm working on the project similar, is that building this gigafactories in India, since you mentioned about that Bangladesh project, right? So that is something we are working on also, building these gigafactories in India, because they don't have any battery manufacturing infrastructure in India. Okay, and they are like 30 years behind Chinese guys in that technology, making the cells and everything. So finally, they are realizing that they have to do this thing. Otherwise, it will be a problem, especially then when you have some political tensions and everything, right? It doesn't make sense to buy cells from them and to go war with them with their own cells, right? So it is a problem for them. Now they are facing. Okay, so there is a big interest in building this gigafactory. So I'm talking to them. I'm trying to help them how they can build the gigafactory. So we are trying to get a contract from them. What we are telling them is, we'll come and build this factory for you, pilot line, and then you can decide. You give us a contract for making pilot line, and after that, you will get a lot of know-how, and we can expand that thing. So that is also a related thing I'm doing now. Yeah.
So when you working with, say, Indian Gigafactory, are you going as a technological partner, or you're going as a consulting services? How you're approaching that? Just curious.
we are approaching as a contractor. That is what we want to do. We found that the consulting and other things are not useful. Okay, it is a total waste of time. It is not helping anybody. So we are going as a contractor. What we are telling them is that we actually have this Korean, Chinese, and other interesting partners companies we are talking to. Okay, so everything is we have the access to this material expertise and everything. The instrument and everything. And what we are telling them is that give us a contract for making, for example, like 2,000 cells per day. Okay, pilot line, and we will build that for you, and then and we will train people for you so that you can continue running this operation. And after that, you can decide what size of factory you want to build, and then we can work together. Okay, that is the proposal we are giving. Yeah.
So that company will also have access to your IP in the process.
Yeah, that is an interesting question, because we are telling them you don't even have the existing technology, right? They don't even have the existing technology, graphite, for example. So why don't you start there? And in the future, if you are interested, we can assess out. That is a different discussion. Okay, if you are interested in our technology in the future, because in countries like India right now, they don't need actually that our technology. Okay, even if it is available and ready to commercialize, they don't need that, because they don't even have the previous generation technology. So what we recommend or advise them, most of these companies ask same thing like you just asked. Okay, why don't you give your technology? We are interested. But what we are telling them is that is maybe a waste of time for everybody, right? Because you are behind China, for example, in many years, or many decades. They have the experience of cell manufacturing. So first you have to establish that before you are getting into the next generation battery business.
Yeah.
Okay, that is our opinion we are telling. Yeah.
So you have two products in a sense. One, you have, of course, the technology know-how to be able to help a company to establish battery manufacturing, where you're working as a contractor, as you said. But at the same time, you have a technology which is almost like a future technology, where you have a advanced anode, right?
That's right. And the other material I just mentioned. So basically, like you said, we are working on two projects that is helping people to without know-how to actually establish manufacturing, the cell manufacturing, and then also develop the next generation battery material technology. Yes.
Because and you mentioned you have Korean and Japanese partners there as well.
Yes.
Because the battery manufacturing is not controlled, maybe the right word, but dominated by top 5, right? So you are working with the top 5.
Yeah, I mean, the top 5 people won't work with us. I can tell you that straight away. Okay, the top 5 companies are not going to work with us. So we are working with other companies, Korean and Chinese companies, who are actually doing the cell manufacturing, instrument manufacturing, and everything, and then use their technology and our expertise to actually make it. The top 5, that is, if top 5 companies will not cooperate with anybody, because they don't have to. Actually, the Indian government, they tried a lot to bring the top 5 companies into India for manufacturing, but they are not interested, because they are full of, their operation. They cannot even make their requirement right now. Okay, so they are so busy that they cannot even make whatever their requirement. So how they should go there? Why they should go to India and set up this plant. So even if we want to talk to them, they will not talk to us. The top 5 battery manufacturers. So that is why we have identified other players who have similar expertise there. And most of the time, these are companies formed by the guys coming from these top 5 companies. Okay, and then we have a discussion going on, and for that, with our expertise in this space, materials, batteries, cell manufacturing, and their expertise, we believe that we have a solid background to actually go and build this plants in India. Yeah.
And these are all OEM companies that you are talking to, right? Of course.
The companies in India, we are talking basically OEM companies, in the sense that solar cell manufacturers, for example, so they are already in the business of energy storage. So they are right now buying cells from China, and they want to change that. So they want to manufacture their own cells. Yes, those are the companies we are talking.
Yeah. Let me try to understand a little bit about your vision about the electricity industry. Batteries and electric car is basically battery on wheels, right? When you have that much storage at home, that will fundamentally change the way we do power distribution and peak demand and others? Have you had time to think through, or do you have a view on how that landscape might change because of all the storage thing that you are bringing in?
Yes, I have some interest in that space also. If you remember when they started distribution of electricity, there was a dilemma that whether you go for DC electricity or AC electricity, right?
Yep.
When they start. So if you go back the story, I think they made a historical mistake moving to the AC electricity. It would have been DC. Okay, that's my opinion. So being said that in the future, you see homes where the car or their vehicle might be enough to supply your power. Okay, means you can combine with the solar or any other things. You can store your energy enough into your car, or you may not need any separate power walls or anything to build. Okay, and so eventually it will be completely like independent, DC powered systems that is charged by renewable energy. Okay, and the distribution, long range distribution is a waste. If you calculate that, right, it is a really lot of waste of energy is happening during the distribution. So you don't have to do that. Everything will be locally made, and you can have your own energy source in your home, completely independent. Okay.
Yeah. Good, fantastic. Because I think I have a similar view, because average person's daily consumption is 10 to 20 kilowatt hour a day, and your car can have 100 kilowatt hour of battery. That is almost an entire week's supply, right? And that can be charged from anywhere.
Exactly.
Okay, this is good. So are you doing any other startup in that off-grid energy space, or you are already fully occupied with your batteries?
Yeah, I'm fully occupied. See, like I said, I'm working on this company for last 10 years. Okay. And right now we want to finish. Maybe it will take another 5 years for us to sell the company. Okay. And then I will think about what else I can do next.
What do you tell a young entrepreneur who wants to get into this space? A lot of young people I talk to are very interested to get into batteries, not sure how to get in. So what will you recommend them to, if they want to get into battery business?
So the battery industry it is not easy for somebody to get into. Okay, I can tell you that, because you need a lot of background knowledge. Because in our case, we both are PhDs, we have our own background experience and everything. So if you don't have that experience, okay, how do you start a company and make it successful? That is a problem. Okay, so you have to be the young people, they are coming out from college. I know a lot of companies are there, right, in the US also. Okay, they prefer some investors, college kids, right, because they think that is a better way to go. So what happened is that a lot of other technologies you can hire people and do it, right? It is possible. But in the battery space, it is not that easy that develop a technology. For example, battery technology is slow thing. Okay, adoption is very difficult. Like I said, we are working on this 10 years. Okay, for us to maybe getting into the market and the mass market. So normally it will take like 20 years of development work. Okay, for a battery technology for the industry to adopt, even what we are talking here, right? Even if it is a fantastic technology and everything, so the young people who are getting into, they have to keep that in mind. Okay, it is not that something I can do the company because I want to do it, because starting a company is very fashionable, and batteries are right now a hot area, so I can do this thing. Okay, so but if you think that way, it's not going to work out. You have to have a long-term vision and think about that. You get into this, and you may need like at least 10-20 years to get out of this business. Okay, so if you are interested doing that, only then get into this.
So someone who is studying in university, they can focus from there, right? Because it's a advanced field of chemical/mechanical engineering ultimately, no?
Yeah, if you are doing maybe your PhD or doing something like that after that, then and if you have some research you have already done in this area, any of this we are talking, right, anode, cathode, or solid electrolytes and other things, then you can easily getting into the battery business if you have that technology, access to that technology. Yeah.
The other question I have is there must be only handful number of people who understands what you are doing in the details of it, no, globally. There are not many
Yes.
people.
Yes, that's right.
So do you do a lot of writing, or you just been working? Do you publish many things?
Yes, yes, we publish also. A lot of technical and other things we publish. Yeah. I can send you a paper, okay, which we have published, technical paper. Yeah.
Okay. So where do you see yourself in 5 years' time now? I mean, this is, it's a big
Yeah.
battery.
Yeah, 5 years time, what I want to see is finish everything, most part of this thing, at least the anode technology, which I'm working on, and commercialize it, large scale manufacturing. I want to see some of the gigafactories building. I want to right now working on that running, up and running, and then ready to start into the next venture. Okay, whether that may be making the sulfur cathode or something else. Yeah.
Because now COP26 is happening and the climate change discussion. So what you are doing can significantly contribute to helping us to mitigate climate change, right? The storage.
Yes, that is very important. That is interesting. You're talking about that, because if you take graphite, whether synthetic or natural graphite, you have to have for each kg of that material, you need to emit like 20 kg of CO2. Okay, for manufacturing of that. Okay, so this is data out there. I'm not just making up. Okay, it is out there. If you make a 1 kg of graphite, synthetic, or whether it is synthetic or natural, you have to spend like 20 kg of CO2. Our material,
yep,
yeah, 20 kilo. Yeah, our material, which since we are making from agriculture waste, it is almost zero CO2 emission. Okay, so that is a big difference if you calculate everything. Okay.
So 20 kilogram of CO2 per kilogram of, or per?
Yeah, per kilogram of graphite. Per kilogram
graphite.
Of graphite.
Okay.
Yeah.
And in your case, if you are using agricultural waste, you may be also capturing some methane there, no?
Yes, methane emission I haven't calculated. Okay.
No, I'm saying you will be capturing in your process some methane as well. So side by side, it may be huge, 20 kilogram of CO2, as opposed to you're actually almost using as a carbon absorption, no?
What do you mean methane absorption by the plant?
No, I'm saying methane is there in the agricultural waste that you're going to use. So basically, you do a sequestration of methane in your anode somehow, no? No?
No. We are not taking the methane part of it. We are taking only the hemicellulose part of it. Okay, hemicellulose. Okay. Yeah. So we are not. I haven't thought about that. But that is an interesting discussion, because some of these companies which I'm talking, they are actually interested in making methane and use for biomethane, a natural gas replacement. Okay, so that is what they want to do. They actually want to do what they told is like you mentioned, and now you are telling about that. So I'm just remembering that what they told me is that they can make methane from this. Okay, biomass. Okay, they can make it, and they have technology. And what they want us to do is that remove that hemicellulose part from the biomass. Okay, so that will be our feedstock. Okay, then we give the remaining stuff to them so they can make methane out of that.
Yeah. Okay. So that's what I was trying to understand. Because if you are capturing that methane, that also helps, because methane is 22%, 22 times more potent than CO2. So if you capture, you don't let it go to the atmosphere.
Yes, exactly. That is something just not something we are doing right now, right? But the discussions are going on how we can capture the methane and integrate this into the manufacturing of our material. Okay.
Yeah, but that can help you to also get some carbon trading funds.
Carbon credit, right? Carbon credit.
Yes. Credit that you might be able to trade for.
Yes.
If somebody wants to establish a factory, that may be another cash stream. I'm just thinking loud. I'm not from the industry.
Yeah. Okay. Yeah, that is an interesting thought. The thing I remember about that is, the project we are going to start is that, somebody is interested in the rest of the biomass and make biomethane from that. Okay. So that way we can actually reduce the cost of the biomass, for example, and the waste from our process can be avoided. Okay, so yes, that is also an interesting thought, methane integration. Yeah. So if you even if you don't calculate that right now, my point is that the CO2 emission is a big difference with the natural and the synthetic graphite and what our technology. Yes.
Yeah, and then this can bring in additional dimension to it.
Yes.
When do you? I'm just again as a personal question. Now.
Yeah.
Climate change is real. I mean, a lot of people went through a different sort of journey as to believing that it is real. Can you remember a sort of like a penny drop moment when it dawned on you saying, yes, climate change is real? Can you remember a point? At what point?
I was I'm basically being a chemist and a scientist. I was knowing that from the beginning. So that is why I wanted to start this company, right? 10 years back when we wanted to start this thing. That time it was not exciting like this. Even the battery technology or even the climate change and all those things, people were not thinking about that. Okay, now it is like you said, everybody is thinking, and it is becoming acceptable that you have to replace graphite, because it is not sustainable. All those things. It is fundamental thing, right? So maybe 100 years back they started the gasoline business, right? So they never thought that is going to be, I don't know, or they were just ignored that, right? When they were building the gasoline based transportation and everything, right? It was obvious that it is going to make a problem, right? It is smoking carbon dioxide, producing carbon dioxide, and it is going to affect everything. But then that time people never paid attention, or they never thought, or they intentionally or unintentionally, that happened. So my point is that right now you are again starting a new industry, okay, or new thing, and you have to be careful that you are not going to get into the same problem like before. Okay, so that is my motivation.
No,
Yeah.
thank you. I mean, I really learned a lot of things. Is there anything else that I could have asked you? Really fascinating what you're doing.
Yeah, thank you very much. So anything, people normally, the investors will ask, why do I care about this thing, right? Even if I tell them all these interesting stories, right? So only thing I want you to keep in mind also that our aim is not only improving this aspect, the greener aspect, and make it sustainable, but also you have to improve the performance. Okay, that is also an interesting aspect I want you to keep in mind. Yes.
Thank you, Vinod. Thank you very much for your time. I learned a lot of things.
Thank you for joining us this week. If you haven't done so yet, subscribe to our show. Also, leave your comments and review if you enjoyed today's episode. Follow me on LinkedIn and Twitter at @shasni for updates. That's SHASNIE. Once again, this has been Energypreneurs, connecting you to the innovative opportunities in solar power, batteries, and electric vehicles. Stay tuned.